basicity of the amines, and in the basicity of the amines we have seen that the various factors that affect the basicity of the amine. So those various factors that affect the basicity of amines are majorly these three. One is solvation, another is steric hindrance, and the next one is a inductive effect. We have even seen that the cumulative effect of these three factors determines whether the amine is going to be how much basic. So let us try to understand the comparison of these compounds with the uh, ammonia. And when we compare these compounds with the ammonia, we find that the arylamines are um, less basic than the ammonia, whereas the aliphatic amines are more basic than the ammonia, and that is what it happens uh, due to the inductive effect. And the next study that we need to do is about the alkyl amine versus ammonia. So let us consider what happens when we have the alkyl amines. As the other effects are involved in this little difficult to interpret or understand, to come to any conclusion, the value of pKb given in the table. So all this effect cumulatively gives us a final result. Structure and basicity relationship of the amines. Now let us study that. Basicity of amine is related to the structure. Basicity of amine depends upon the ease of formation of cations by accepting a proton from an acid. So bases, they generally accept protons and form the salt. The more stable is the cation, is relative to the amine, more basic is the amine. So if the cation is formed, the new formed cation, if it is more stable, then the basicity of amine is more. So now first let's look at the alkane amines versus ammonia. Let us consider the reaction of alkane amines and ammonia with the proton. You can see here this is the alkyl amine, whereas this is the ammonia. So first alkane amine reacts with H plus to produce the quaternary ammonium salt. Ammonia also produces the NH4 plus salt. Due to the electron releasing nature of alkyl group, you can see that this alkyl group has got the electron releasing nature, and it releases or it increases the density on it increases the density on nitrogen because it has got, whereas hydrogen has electron not donating but electron withdrawing nature. So this is what it in case of the ammonia and alkane amine takes place, that due to the electron releasing nature of alkyl group, alkyl or substituted amines have more availability of electron on nitrogen to share with the H plus as compared to the ammonia, and that is why we can say that moreover alkyl substituted ammonium ion get stabilized. So first thing that comes to our mind is about the ability of alkyl group to donate the electron. As alkyl group donate the electron, the availability of electron on nitrogen is made easier. Same way, my dear students, due to the dispersal of the positive charge by plus I effect of the alkyl group, hence alkyl amines are stronger base than the ammonia. So due to the ability of alkyl group to donate the electron or plus I effect, they are more the alkyl amines are more basic than the ammonia. Basic nature of amine should increase with the increase in the alkyl group. So as the number of alkyl group increases, the basic character should increase. This trend is followed in the gaseous phase. Now, my dear students, when we are studying this point here, it is going to be very important point for us. This trend, whatever we can see, this trend is followed in the gaseous state. So this trend generally is being followed into the gaseous phase only. In the solution phase or in the other phase, this trend is not followed. But for gaseous state or for gaseous primary, secondary and tertiary ion, we can say that the order of basicity of amine in gas phase follows the order. Tertiary amine is more basic than secondary amine. Secondary amine is more basic than primary amine, and primary amine is more basic than ammonia. This is what we are talking about, the alkyl amines. So in case of the alkyl amines, in the gaseous phase, we can say that tertiary amine is more basic than secondary amine, and secondary amine is more basic than primary amine, and primary amine is more basic than ammonia. So we can say it is 3 degree is greater than 2 degree is greater than 1 degree is greater than 0. Now in the gaseous phase, this is what we have studied. When we add any amine into the water, now it comes to the addition of amine into the water. That means it's a discussion about the aqueous solution. When we add any amine into the water, RNH2 plus H2O, it forms the RNH3 plus and OH minus. R2NH will form R2NH2 plus and OH minus. R3N will form R3NH plus and OH minus. So this is how the ammonium salts are produced when any amine is added to the water, and these are the ammonium salts. In water or aqueous phase, the substituted ammonium cations get stabilized not only by the electron releasing effect of the alkyl group, that is plus I effect, but also by the solvation with water molecules. So here, when it comes to the addition of amines into the water, the solvation also comes into play, and that also start the affecting the stability of these cations. So these cations, their stability depends now upon two things. First is plus I, and another one is solvation. This solvation here in case of water, we consider it is the as the hydration. The greater the size of the ion, please remember that the more bigger is the ion, the greater is the size of the ion, lesser will be its solvation, and less stabilized is the cation. Here the ion what I am talking about is actually the cation. So if the size of the amine, or if the size of the salt or cation produced is more, it will be less solvated, and that is why it shows the it shows the lesser stability, and lesser is the stability, lesser would be it's a basicity, and therefore the order of stability, if we write the order of stability of ions, the primary amine is greater than the secondary amine is greater than the tertiary amine, because primary amine forms the smallest cation, secondary amine forms the bigger one, and tertiary amine makes the biggest one. One more thing is here that a primary amine will make more hydrogen bonding, a secondary amine will make lesser hydrogen bonding, and tertiary amine will make the least hydrogen bonding. Thus, in the aqueous solution, the stability of this cation is primary cation is greater than the secondary cation, and it is greater than the tertiary cation. Same way, decreasing order of extent of hydrogen bonding. Now, if you think about hydrogen bonding, decreasing order of extent of hydrogen bonding and order of stability of ions by solvation. The same is also the order. Primary is greater than secondary is greater than tertiary. The same is the order even for the making of the hydrogen bonding. Primary amine can make more hydrogen bonding as compared to the secondary, and secondary amine can make more hydrogen bonding as compared to the tertiary. Greater the stability of substituted ammonium cation, stronger should be the corresponding amines as a base. So greater is the stability of the cation, of this cation I am talking about, whatever the cation among these three is more stable, it is going to be more basic in nature, or their corresponding amine is going to be more basic in nature. So in water, the order of basic strength seems to be primary is greater than secondary is greater than tertiary. So now we have studied that in gaseous state the order was exactly opposite. It was tertiary is greater than secondary is greater than primary. But in the solvation, or when we think about the solution of ammonium or amines, the order should be primary is greater than secondary is greater than tertiary, because the stability of cation should be primary is greater than secondary is greater than tertiary, which is exactly opposite to the order due to the inductive effect. So apart from inductive effect and solvation effect, there is one more reason which is known as the steric hindrance that affects the basic strength of the pKb value. Now let me explain a little bit about steric hindrance. Suppose you think of amine, and if it is primary amine, then we have only one R, whereas the other two are hydrogen. But if it comes to the secondary amine, it has got two alkyl or aryl groups, let's say alkyl group. And if it comes to the tertiary amine, you can see that the tertiary amine will have three alkyl group. So as far as steric hindrance is considered, it has got, tertiary amine has got highest steric hindrance, whereas primary amine has got lowest steric hindrance. So these are the three different uh, factors that affect the basicity of the amine. So when alkyl group is small, like methyl, there is no steric hindrance to hydrogen bonding. But bigger ethyl group cause steric hindrance. Thus, change in the nature of the alkyl group, example from CH3 to C2H5, result in the change of the order of the basic strength. So, third factor also affect, or third factor which is known as the steric hindrance, that also come into play when we are talking about the basicity of amines, and as the number of carbon increases, the steric hindrance also increases, and thus this steric hindrance also affect the basicity uh, of the amines. There is a subtle interplay of inductive effect, solvation effect, and steric hindrance. Now all these three comes into play, and they interfere each other's effect, and they give one final effect of the alkyl. So we have three effect: inductive effect, solvation effect, and steric hindrance of the alkyl group, which decides the basic strength of the alkyl amine in the aqueous state. In order of basic strength, in case of the methyl substituted amines and ethyl substituted amine in aqueous solution is given here. Now this is the order that we need to remember, my dear students, that this order is the final order that can be understood for the various types of amines that we are discussing. So for ethyl substituted amines, if you think about, then the order is secondary ethylamine and tertiary and then primary and then ammonia. So when it comes to the diethylamine is more basic than triethylamine, and triethylamine is more basic than monoethylamine in this case, whereas ammonia is the least basic among all this. So you can remember this order 2, 3, 1, 0 when you have two carbon. When you have two carbon, you can say it is 2, 3, 1, 0. But when you have methyl substituted amines, that dimethylamine is more basic than methylamine, and methylamine is more basic than trimethylamine due to steady. So this is how, my dear students, for primary amine you can understand the effect as 2130. Now I can give you a small hint to remember this, that if you have ethyl group that has a C2H5, then it is 2310. Both have secondary, whether it is methyl substituted or ethyl substituted, both have the secondary amine as a most basic. But when it comes to the methyl, the one carbon, that is primary amine, is more basic than tertiary amine, and in case of the ethyl amine, tertiary amine is more basic than the primary amine. So you can remember the order as ethylamine 2310, ethylamine 2310, methylamine 2130. You can remember this methyl with this one. At second position, methyl has one carbon, second position one carbon, that's all. So when it comes to the methyl, it is 2130. When it comes to the ethyl, it is 2310. This is how you can remember, because there is no logic that we can apply. We'll have to accept this practical observation, and we'll have to accept that this is what it is the case when it comes to the amines which are either methyl substituted or ethyl substituted. Now we want to study about the aryl amines, and in between, if you have any doubt, my dear students, you can ask. Do you have any doubts? Dear students,
No.
is there anything which you cannot understand?
No.
Okay.
No.
Let's move forward then. Arylamine versus ammonia. Now, until now, we have studied about the aliphatic amines. Now we want to study about the aromatic amines or arylamines. pKb value of aniline is quite high. Why is it so? What is the reason that the pKb value of aniline is very high? It is because in the aniline or in the arylamines, the NH2 group is attached directly to the benzene ring. It results in the unshared electron pair on a nitrogen atom to be in conjugation with the benzene ring, and thus making it less available for the protonation. You can see, my dear students, that in this the electron present on amine undergoes the resonance, and we get these 5 various structures. These 5 various structures are because the electron from nitrogen undergoes the resonance. It involves itself into the resonance inside the aromatic ring. So thus you can say that when an amine group is bonded to the aryl group, uh, the electron present on nitrogen undergoes the resonance, and that is why they are less available for protonation. Aniline is resonance hybrid of the following 5 structures. So actually whatever aniline we see is the resonance hybrid of all these 5 structures. On the other hand, anilinium ion obtained by accepting a proton can have only 2 resonance structures. So when your aniline gives, or it reacts with NH plus and gives you NH4 or NH3 plus here, this is what it is known as the anilinium ion, and this anilinium ion has only 2 resonance structures, and that is why it is resonance stable, but the resonance structures are less, and that is why it is less stable than the aniline itself. We know greater is the number of resonating structures, greater is the stability, and that is why aniline is more stable than anilinium ion. Please remember, this question has been asked quite a few times into the exam, that why aniline is more stable than anilinium ion. As aniline is more stable than anilinium ion because of the resonance hybrid, aniline has got 5 resonance structures, whereas aluminium ion has got 2 stable structures or 2 resonance structures, and that is why this anilinium ion is less stable as compared to the aniline. And we can say that aniline is more stable than the anilinium ion because it has got 5 resonance structures, whereas the anilinium ion has got only 2 resonance structures. The equilibrium is established if it is there. If there is an equilibrium established in these reactions, most of the time the reactants are available in the major quantity, and that is why we can say that the reaction between the aniline and H plus is not much possible. Equilibrium remains shifted to the left side, and that is why addition of H plus is difficult because aniline is more stable than the anilinium ion. Thus, aniline does not easily accept H plus as compared to ammonia, and that is why ammonia is more basic than aniline. That is why basic strength of aniline and other aromatic amine is less than the ammonia. So we can easily now understand why aniline is less basic than ammonia. Even you may be asked this question, that why aniline and other aromatic amines are less basic than the ammonia. You can easily explain this by using the resonance structures. In case of the substituted aniline, electron releasing group like OCS3, CS3 increases the basic strength, whereas electron withdrawing group like NO2, SO2, COOH, halogens decreases the basic strength. Once again, if we have the substituted aromatic amines, the presence of OCS3 group, CS3 group, or any other electron releasing group increases the basic strength, whereas These electron withdrawing groups like NO2, SO3, COOH, and X, they actually decreases the basic strength of the aromatic amines. So now let's understand the um, the idea of basicity that we have studied with few examples. Arrange the following in the increasing order of their basic strength. First, we have this question. Let us look at the question. C6H5NH2, C2H5NH2, C2H5 twice NH and NH3. We know that ammonia is at least more basic than aniline. So that is what we are well aware. Now it comes to the ethyl substituted amine. We know that for ethyl substituted amine we have the order 2310. So secondary is more basic than primary, and that is why we can say that C2H5 twice NH is more basic than primary and then ammonia, and then it comes to the arylamine. So this is how, my dear students, we can write. If we want to write the increasing order, we can write C6H5NH2 is less basic than ammonia, ammonia is less basic than primary amine, and primary amine is less basic than the secondary amine. Same way, my dear students, if you look at the next question, C2H5 twice NH2, C6H5NH2, NH3, C6H5CH2 NH2, and C6H5 twice NH. Again, here you have the arylamines, you have the amines which is having the aryl group, and you can have the amines which is ethyl substituted amines. So we have two ethyl substituted amines, my dear students. One is monoethylamine and another is diethylamine. So we are well aware that diethylamine is more stable than monoethylamine. Then it comes to the uh, then it comes to the amine which is having a phenyl group which decreases the strength, and then it comes to the ammonia, and then it comes to the arylamine. So the most basic one is your diethylamine, then monoethylamine, then phenyl methylamine, then ammonia, and then the least basic is your aniline or arylamine. Now, next question is monoethylamine, diethylamine, triethylamine, and aniline or arylamine. We are very well aware that for ethylamine we have the order 2310, and that is why the 2 is the most, then 3. You can see the 3, then this is 1, and then ammonia, but ammonia is not given, so then even lesser than the ammonia are the arylamines. Next question, CH3NH2, CH3 twice NH, CH3 thrice NH. Now this is the case of the methyl substituted group, and for them we know that the order is 2130. So this is the most, this is the 21, this is the most, then it comes to this, and then your 3 will be in the category. Then you have this aniline and you have the um, phenyl methenamine. So my dear students, phenyl methenamine is more basic than normal aniline, and that is why we can write that aniline is less basic than phenyl methenamine. Then our tertiary comes, and then after tertiary we can go for primary, and then after primary the secondary is the most basic amines. Next question, arrange the following in the increasing order of their pKb value. Now my dear students, more is the pKb value, lesser is the basicity, but here we want to arrange them in the increasing order of pKb value. That means increasing order means lower to higher. This is what it is, increasing order. We know that lower is more basic. So we need to arrange them in the order of more basic to less basic. More basic to less basic. This is how we need to arrange, my dear students. So let us arrange them into the order of more basic to the less basic. You can see here, my dear students, that uh, or C6H5NH2, C6H5NH, CH3, C2H5 twice NH, and C6H5NH2. We are well aware that this secondary amine is the most basic among all of them. So this is the most basic, then the primary one, this, which are aliphatic. These two are the aromatic. This is this methyl group which is present on this nitrogen actually increases its basicity, and that is why this N-methyl aniline is more basic than normal aniline. Same way, my dear students, we have the next in the increasing order of the basic strength. So which one is the most basic here? You can see this is a arylamine, this is arylamine, this is ethylamine, and this is methylamine. So when it comes to the secondary one, it is going to be the most basic, then primary. Then you can see that here with this nitrogen 2 methyl group are present, which increases its basicity, and then arylamine are the least basic, and that is why we can easily write the order as C2H5 twice NH is more than CH3NH2, CH3NH2 is more than C6H5 and CH3 twice, and then we have the arylamine. So arylamine will have the highest pKb value in this case. Now, my dear students, we want to study about in the increasing order of the basic strength for aniline, para-nitroaniline and para-toluene. My dear students, the para-toluene is the kind of compound where with the aniline here, my dear students, with the aniline here, we have CH3 group is bonded. So we are well aware that CH3 group increases the basicity, whereas here nitro group is present which decreases the basicity. So para-toluene is more basic than aniline, and para-nitroaniline is less basic than aniline, and that is why para-toluene is the most basic, then aniline, and then para-nitroaniline. Same, my dear students, in the increasing order of their basicity, if you want to arrange them, this is again, you can look at that here we have normal aniline, here with this nitrogen, one CH3 group is present, and here this nitrogen has got two hydrogen, but CH3 group is bonded to it, and that is why we can say that this CH2 is directly bonded to the nitrogen, and that is why the phenyl methylamine is most basic, and then it comes to the N-methyl and finally aniline. My dear students, please remember that this phenyl methylamine is actually a kind of aliphatic amine, not an aromatic amine, and that is why its basicity is even more than the ammonia. Decreasing order of the basic strength in gas phase. Now, my dear students, please remember that in gas phase we have studied that amines have the order of tertiary is greater than secondary is greater than primary. So as far as the order into the gaseous phase is concerned, my dear students, we are going to follow this order that tertiary is greater than secondary is greater than primary and then ammonia, because aliphatic amines are more basic than ammonia always. Then next, in the increasing order of boiling point. Now here we want to study about the boiling point. Boiling point depends upon the hydrogen bonding, and hydrogen bonding actually depends upon the presence of hydrogen. So you can see that here two hydrogen is present, here one hydrogen is present, and this is alcohol, and that is why alcohol is the most having most boiling point, then the primary amine, and then the secondary amine. Increasing order of solubility in water, my dear students, we have seen that in water solubility the order is primary is greater than secondary is greater than tertiary, and that is why we can write the order as primary is greater than secondary is greater than not tertiary is given, and that is why if not tertiary then it comes to the phenyl or arylamine, and that is how we can arrange these various compounds into the increasing order. So please remember all the orders. You can expect at least one question from all the discussion that we have. Now, these are the very important questions, and I generally have marked that from all this discussion, increasing and decreasing order, at least one question will be asked into your board exam also. So this is what I have explained today is very important, and please learn it well. I have considered all your in-text and exercise questions of increasing and decreasing order. So I hope you understood. If you have any doubt, you can ask me, or we can move to the next portion, that is the question. Why activating effect of NH? Is there any question?
No, sir.
Is there any question from you, my dear student? Okay. Why
No.
activating effect of NHCOCH3 group is less than that of the amino group? So, my dear students, we want to understand that the activating effect of NHCOCH3 group is less than that of amino group. Why? Uh, my dear students, we can easily understand this answer if we pay attention. Please pay attention. The lone pair of electron on nitrogen of acetamide, this lone pair that is present on this electron, that is present on this nitrogen I am talking about. So the lone pair present on the nitrogen of the lone pair present on the nitrogen of NHCOCH3, this nitrogen I am talking about, it has got the lone pair. So the lone pair present on this interact with the oxygen atom due to the resonance as follows. You can see that these lone pair interact with the oxygen and the electron from carbon goes to the oxygen. So here when there is double bond and here the double bond is being broken. Again, when the electron of double bond comes on nitrogen, then oxygen gives its electron to form the double bond between carbon and oxygen. So what we simply understand here, my dear student, is that when it comes to the NHCOCH3, which is directly bonded to the aryl ring, you can see that this electron present on the nitrogen, I'm talking about this electron, they interact with the oxygen and this is how the resonance structure is formed in case of the NHCOCH3 if it is present on the aryl group. Hence, the lone pair of electron on nitrogen is less available for donation to the benzene ring for the resonance. So, for the resonance and by the resonance. Therefore, activating effect of NHCOCH3 group is less than that of the amino group. So, on the aryl group, my dear students, C6H5, if you have NH2 group is present, it shows more deactivating effect and because this electron can be easily involved. But if you have NHCOCH3, then the electron present on this nitrogen actually interact with this oxygen and that is why they are more available to be donated, they are more available to be given to the phenyl ring for resonance. And that is why NHCOH3H3 group is less deactivating as compared to the amino group. And by using this, we are going to study the various reactions of the amines where we are going to use the less deactivating effect of our NHCOCH3 group. Now, my dear students, we want to study about the reaction of the primary aliphatic amines with the nitrous acid that we will study into the next period. Let us revise whatever we have studied today. So, in the today's class, my dear students, we have studied about the basic strength of the various amines. We have seen, my dear students, that in the the structure of the amine determines basicity and it helps into determining the basicity of the amines. We can see that the stability of this cation which is formed by the amine determines its basicity. The more stable is the cation, the more basic strength we can see into a particular amines. When it comes to the gaseous phase, the stability of amines are tertiary is greater than secondary is greater than primary is greater than ammonia, that is 0. But when it comes to the uh, aqueous medium, there are three different factors that comes into play. These three different factors are three different factors are steric hindrance, uh, inductive effect and solvation. So by the cumulative effect of this inductive effect, solvation and steric hindrance, my dear students, we can easily explain or we can easily understand that the ethyl substituted amines will have the order 2310 and the methyl substituted amines will have the order 2130. Now when it comes to the arylamine, my dear students, when arylamine reacts with the water, they produce the ammonium anilinium salt. This anilinium salt has got only 2 resonance structures, but aniline has got the 5 resonance structures. And that is why aniline is more stable and anilinium ion is less stable. That is what we have experienced here, that aniline is more stable and anilinium ion is less stable. That is why when there is an equilibrium established, most of the equilibrium is towards the aniline. So it is difficult to prepare anilinium ion from the aniline, and that is why aniline is more stable than anilinium ion. So anilinium ion is less stable, and that is why aniline is less basic than the ammonia. So all the aryl amines are less basic than the ammonia, and this is how, my dear students, we can easily understand the last point or recall the last point, that in aryl amine, if the electron releasing groups like OCH3, CH3 are present, they increase